Hi everyone, this is Mrs. Turigno, and this is page 3 of the Algebra 1B Semester 1 exam review. I'm actually starting on the bottom of page 2 with problem number 15, but then we'll move on to page 3 and hopefully get through that whole page with this video. Okay, problem number 15 is really quick. It's asking, is this relation, which is really just a set of ordered pairs, a function? When you're determining if something is a function or not, what you really want to look for is you want to make sure none of the x's are paired up more than once. And remember, the x's are the first term in every ordered pair. So it would be the 1 and the 2 and the -1 and the 4 and the 0. Now none of those numbers repeat, which means that this is a function. And for your why or why not, I would simply say none of the x's repeat. That's a sufficient enough explanation. Okay, so I would say yes, because none of the x's repeat. All right, let's move on to that next page, because there's one very similar to that on the top of this page. This is another one where they're giving us a relation and asking us if this is a function or not. This time for my x values, I have a 1, a 3, a -2, and a 1. Notice that in this first pair, the 1 is paired up with 2, and in the last pair, 1 is paired up with 5. That means this is not a function, and I would say because 1 is paired up more than once. When you're looking at functions, keep in mind that you're really only concerned with the x values. The y values can be paired up more than once and it would still be a function. It's the x values that you have to care about as far as determining whether or not it's a function. Okay, on to question number 17. And this video will go down through problem number 20, so it'll cover the entire third page of your packet. This is asking us to find the x and y intercepts of y equals 2x minus 8. For this one, you're going to have to do two separate things. Find the x-intercept and find the y-intercept. Now hopefully you remember what we always know at the x-intercept and what we always know at the y-intercept, because we have drilled that in class over and over and over again. So when I say it, hopefully you at least remember it, even if you didn't know it off the top of your head. At the x-intercept, you always, always, always know that y is equal to 0. So when I'm going to find the x-intercept, I'm going to put a 0 in place of y. So 0 equals 2x minus 8. And then I'm just going to solve. So I would add 8 to both sides. I would end up with 8 equals 2x. From there, I would divide both sides by 2, and I would end up with 4 equal to x. That means my x-intercept is at 4. Now, that's an acceptable way to write this answer because the question is asking what is the x-intercept, but technically this is a coordinate. And so if I were to write it as a coordinate, I would write 4, 0. This is saying that x is equal to 4, so it's in the x spot, when y is equal to 0. And we put a 0 back here for y. Now I'm going to go find the y-intercept. And actually for this problem, the y-intercept is pretty simple. At the y-intercept, you always know that x is equal to 0. So I'm going to write the equation, but this time with a 0 in place of the x. Well, I already have y by itself, so really all I have to do is evaluate this side over here. 2 times 0 is 0, and 0 minus 8 is -8. So my y-intercept is -8. If I were to write that as a coordinate, this time I'm going to put the -8 in the y position because it's the y-intercept, and this time the 0 would go in place of x. So my coordinate would be 0, -8. On to number 18. And in number 18, I'm going to show you a bit of a shortcut for doing what we just did. You could certainly write it out the way we did a second ago, but this is the way we've sort of talked about it in class to just make ourselves a little bit more efficient. If I'm looking for the x-intercept, I know that y is equal to 0. That means this whole y term is going to cancel out, and I will be left with 2x on the left and 10 on the right. So if 2x is equal to 10, that means x would equal 5. And all I'm really doing there is dividing both sides by 2. Again, my coordinate for that, if I were to write it as a coordinate, would be 5, 0, because the x value is 5 and the y value, we put a 0 in there for y. We didn't write out that we were putting in a 0 for y, but that is absolutely what we did. For the x-intercept, for the y-intercept, I'm going to put a 0 in place of x. What you want to be careful of when you do this one is make sure that negative sign stays attached to that 4y. That's really negative 4y equals 10. This time, I'm going to divide both sides by negative 4. And that will come out to a decimal, but that's okay. And I would accept this as a decimal or a fraction. When you divide 10 by negative 4, you end up with negative 2.5. So your y-intercept would be 0, negative 2.5. So there's your x and y intercept. Okay, domain and range. I get lots and lots of questions on domain and range, and they're probably easier than you think. Okay. Domain is just asking, what values does your graph cover along the x-axis? So from left to right, my graph goes from where to where? Well, the furthest point to the left is this one right here. And that's at negative 3. And the furthest point to the right is this one right here, which is at positive 9. The technical way to write this then would be negative 3 is less than or equal to x is less than or equal to 9. Really what I'm saying here is all of the x values are between negative 3 and 9. And I'm using x because I'm counting along the x-axis. Domain always has to do with your x values. So this is your domain. Range works the same way, except now you're talking about your y values. So I'm talking from low to high. What values does your graph cover? Well, the lowest point on the graph is right here on the y-axis, which is equal to 0. And the highest point of the graph, don't be fooled by this, your highest point is right here. And I believe that is 1, 2, 3, 4. So for your range, I would say that your y values are between 0 and 4. And again, that's what this is saying. All of your y values fall between 0 and 4. And I'm using a y because this time I'm talking about the y-axis. Okay. Let's move down to this bottom one, number 20. Again, domain and range. Domain is asking for the numbers that your graph covers from left to right. It's asking for all of the possible x values. Be careful. You want to find the furthest point to the left and the furthest point to the right. The furthest to the left would be this one right here. That point. The furthest to the right, though, is not necessarily this end point here. Okay? It would be this point right here. Okay. By the way, this is a bit of an error here because this graph is not technically a function. You could still find domain and range, but it is not technically a function because it doesn't pass the vertical line test. So just a interesting tidbit of information there for you. Okay, along the x-axis, this is at 1, 2, 3, 4, 5, 6 to the left would be negative 6. And this is at 1, 2, 3, 4, 5, 6, 7, 8, 9. So my domain would be between negative 6 and 9. Okay. range, again, is low to high. And the lowest point on this graph is this one right here, which is at -4. The highest point on this graph is all of these points right here, which is at 4, 5, 6, 7, 8, +9. Okay, so this time my values go from a low point of -4 to a high point of +9. So domain and range would be -4 less than equal to y less than or equal to 9. And I apologize, that's the range. I think I said domain and range, but that would be your range. Okay. All right, that's it for video number 3. Video number 4, we'll pick up with page 4.